Chapter 24, the assess, page 258. This is question 2. There it says, look at these graphs. Okay, looking good to me. Right, what is the equation, it says, of the line labelled y equals some function of x? Well, that's this red one here. What have we got? Okay, y equals mx plus c, it's ordinary grade C knowledge. If I maybe take 2 squares along and 1 square up, that's 1 divided by 2, so the gradient is a half. And where does it intersect the y-axis? Oh, 0, 2. Right, so the intercept, oh, don't get all glitchy, intercept equals 0, 2. So therefore the equation is going to be y equals half x plus 2. Oh, there it is. That's straightforward, isn't it? Lovely. That's that one. And then it says for each of the graphs A, B and C, write their equations in the form of fx plus a. Oh, alright then. Well, here is the ordinary function, and it's y equals half x plus 2. What's happened here? That's going to be y equals half and x plus 2. That's my basic untransformed function. But look what's happened. It's been raised up from 2 to 5. That's another plus 3 units. So what have we got here? Y equals half an x plus 2 plus 3. So if I can just carefully put a little box around that bit, that's my original function, and I've got therefore y equals f of x and plus the a bit. Well, the a bit is this 3 that I raised it 3 units, so it's going to be fx plus 3. Not sure how the answer book wants it, but based upon the original function, the untransformed function, I've got my half x plus 2 encoded there as part of my original f of x, and all I did was just lift that function up 3 units. Now I can see very clearly that I know what the equation of the transformed function is, and I'll tell you what that is later on. That's in part C. This one here, well, this one's going to be y equals the original function of x, and I've gone from 2 down to, let's just use blue again, I've gone down to 2 down to minus 1, so I've dropped it 3 units, so it's going to be y equals function of x minus 3 units. Easy, isn't it? Alright, and this one here, I've got y equals f of x, and what's happened? I've gone from 2 down to minus 5. So from 2 down to minus 5, I won't draw a blue line there, I'll just speak it. 2 down to minus 5, I've gone 7 down. So f of x minus 7. Right, that's that done. Work out the equations of lines A, B and C properly in the normal way, y equals mx plus c, and show that you get exactly the same answers as you get in B. Well, alright then, I'll work on this side then for A. Let's work in blue. So let's look at A then. What have I got? I've got a gradient as before. They're all parallel, of course, because they're all transformations of the original function, and that's straightforward. So that's 1 divided by 2 is a half. So here I'm going to have the gradient of a half again, and the intercept is going to be 5, and let's call it 0, 5 as a coordinate. So therefore I've got y equals half an x plus 5. How does it compare with the original transformation? Y equals f of x plus 3, so y equals half x plus 2 plus 3. So let me explain that further. Y equals the original function of x plus 2, that's the red line there, there it is, y equals half x plus 2 here, and then add on 3, and that becomes y equals half x plus 5. Therefore the y equals half x plus 5 is exactly the same as the y equals half x plus 2 plus 3 from before. Same thing, isn't it? Now this one here, same way. I've got a gradient of, let's have a look, 2 units across, 1 up. So it's 1 and 2, just like here before. 1 and 2 here. It's getting a bit cluttered, I'm sorry. That's a 1, isn't it? 1 square up, 2 squares across. So here, exactly the same again. 1 unit up, 2 units across. Alright? So what have I got here? I've got y equals the original half of x plus 2, and I've dropped down 1, 2, 3 units, so minus 3. And this becomes y equals half of an x minus 1, because 2 minus 3 is minus 1. And look where it crosses, minus 1. Therefore, I've retained the equation there, y equals f of x minus 3. Do a quick calculation, and therefore y equals, what's the f of x then? Sorry, half x. So y equals half an x and plus 2, that's the original function, and then minus the 3, that's why I get y equals half of an x minus 1. So I've done it there and I've done it here, and it's easy. And finally we'll work here. Again, the gradient is 1 unit up, 2 units across, 1 in the y direction, 2 in the x direction. The gradient is a half, so I've got y equals half of an x minus 5. Where did I get that from? Well, I've got y equals half of an x, what's the original? Plus 2, that's my original f of x, and I'm going from plus 2 down 7 units. Okay, so I'm going from plus 2 and then subtract 7. So let's apply that here. Y equals half of an x plus 2, then take away 7, and that becomes y equals half of an x, and of course 2 minus 7 is negative 5. That exactly matches that equation there, and it fits with this function here as well. Remember, the original f of x is y equals half of an x plus 2, and then I came along and dropped it 7 units, and 2 minus 7 of course is minus 5. So the whole mathematical thing holds really nicely together, and I think I'll stop question 2 there. Short little video, very, very easy, no difficult function, no horrible squiggly little graph passing through very difficult random points. Lovely straight line, lovely linear graphs. Lift it up, drop it down. That's all there is to it. Yep, that's it. Simple. Catch you later for the final video.